Okay, good morning, everyone. Shall we start? OK, ザフィラさん、could you start?
Can you hear me, Sensei?
Yeah.
Okay. So yesterday we discussed about so I compared this is the sections.
Yeah.
So the ductility is 4,
Yeah.
means that the yielding at the middle. And then when I change to direct functions, so I change this based on the metallic damper, the Adder's damper. And then here I make it elastic. And here I set as 690. So the ductility actually less than the one that we use in the sections. But however, if we change the opposite side, means that
Sorry. You are too fast. Could you start again?
Okay, this is the section. So the size that we choose is from the beam size, and then we change the properties of hysteresis.
Okay, it's a hysteresis damper for just spring.
Okay.
And you compare this result with
the direct function, the different how can I say, the input. So this one is from direct. So we have MR and QR.
Okay.
Okay, and this one is where the shear force at the middle, the metallic damper at the middle. So MY should be elastic, and QR we set as same as the Adder's damper, so which is 690 kilonewton.
One more.
Yes. And then, okay, can I proceed, Sensei? And here the ductility is 1.8. And then when we discuss, we want to make sure the metallic damper at MR. So MR is here. So 660 times by 1.2, because the length of the beam actually 3 meter. But we have to minus this column size.
Yeah.
So it's 1.2. So this MY should be 870. And from here, we can get same ductility as the metallic in the middle. So 1.8 here. But the middle part should be elastic.
Did you change Young modulus under E and I?
Yes, this is based on the Adder's damper.
This is based on the Adder's damper.
Yes.
Could you go back one slide?
Here.
Okay.
So,
but this result is different from the
section. Yes.
Yeah, this one.
Yes. If I change here, Sensei, the size as a metallic, as a Adder's damper, the problem is the yielding will be flexure, not in shear. So at the both side we fit instead of in the middle.
Okay, could you send this
model
slide? Yeah, and the model also.
Okay, and I also checked the drift. MR and QR, it have same sorry drift and also acceleration, but I want to ask about the ductility. So MR actually bigger than QR. Is there any reason?
Oh, but the same hysteresis, why ductility is different?
I think maybe because now one is MR, another one is QR. I'm not sure how they calculate.
Definition of ductility factor is the same. Okay. I will check also.
Okay, Sensei. Okay, yes.
Okay. Today's 20. Let's see. Can I meet you tomorrow morning?
Oh, okay.
How about 10 o'clock?
Okay, sensei.
Okay.
No problem.
Yeah. Let's finalize your model. So, okay. Okay, so who is next? Ataya-san or Sara-san, maybe? Sara-san, do you have anything you can show me?
Yes, I have.
Hmm. Sara-san, I cannot see anything.
Okay. 今はどうしますか？
Not yet. It's start sharing the screen, but nothing appear. No, nothing appear.
Oh.今はどうしますか？
No,
Oh.
nothing.
Not yet.
Not yet.
Oh.
Why? Did you change your computer?
Please, can you present the next person?
Okay.
Yeah, I should prepare my presentation. Okay.
Yeah, okay. Ataya-san, maybe. Could you explain? Just Sara-san, could you close your window sharing? Sara-san. Okay. So Ataya-san, your turn.
Yes, Sensei. Sensei, I checked this to become non-linear, these 2 points.
Okay, okay, yeah.
And the result didn't change. It is one of the floors, the displacement of one of the floors. The orange is with TMD and the blue is without TMD, and it is not. It is the same as nonlinear sensei. Didn't change the result.
Oh, okay.
And I
Mhm.
tried this for a frame of one story also. The result is the same.
Mm. Did you compare with the lumped mass model?
Yes, since with lumped mass model, when I decrease the stiffness and damping,
Mm.
then the effectiveness decreases. It means that with TMD and without TMD is almost the same. But for frame model, nonlinear and linear results are the same if we decrease the stiffness of TMD.
Fine. Mm. Mm. Could you click option structure here? What how about the freedom? 2, 4. Okay, only X direction.
Yes, sensei.
Only X direction. And could you, where the TMD is located?
The top
Story?
floor. Yes, the 8th story.
Mm. Is there a column under, I mean, this point? There are column?
No, sensei.
No?
And also, I tried in another model that under this two is column. Also, the result is the same, sensei.
Okay. Could you do? Could you go to structure, option structure again? And maybe you consider only horizontal components, so you can put 2, 3, 4, 5, 6, 7, 8, except one. Yeah. And I believe this result should be similar to lumped mass model because the freedom is only horizontal direction.
This should be linear, sensei?
Linear is okay.
Okay, sensei.
No.
Sorry, sensei, it is very slow in frame model analysis.
No, I'm waiting.
No, sensei, it is decreased as well. It's very small, sensei.
Why? let's see. Okay, let's do like this. One story building,
Okay,
and
sensei.
one is frame. So this is, for example, one story building with TMD on the top. And
Okay,
another one is lumped mass model with TMD on the top. So you compare the result. And both restraint freedom, I mean, we allow only X direction, one. And main structure, mass and stiffness should be same as lumped mass model.
okay, yes.
And it must be same.
But in the frame model, should I divide the shear force to the displacement to find the stiffness, sensei?
You can do some pushover,
Okay, sensei.
and you can find the story drift under shear force, and you can adapt this stiffness for lumped mass model.
Oh, okay, sensei.
Yeah. So after if still you have a difference of result, maybe I don't know, but please first check. I mean, yeah, please compare frame and lumped mass model only for single story and elastic.
Sensei, I checked that for this for 6-7 for one story also, but not for only release one direction.
Well, if you allow rotation, it might be rotating around the PMD.
Oh, okay, sensei.
So I don't want to. I want to avoid this
Oh, okay,
component.
sensei.
Yeah.
Okay, sensei. I will do it.
Yeah. After you get the result, please let me know. Okay.
Yes, sensei. Okay.
Okay, Sarah-san, are you ready now? Sarah-san. No response.
I think she tried to reconnect again.
Okay, so anyone who want to discuss?
Sorry, sensei, one question. According to the letter that you sent me, sensei, the English version is okay, or I have to be waiting for the Japanese version as well? The letter that you sent me for GIP office.
You mean letter of recommendation?
Yes, yes, sensei.
Yeah, I sent you English version.
Yes, I mean that that English version is okay.
What do you mean? Okay.
Yeah, I thought the Japanese version.
Really? It must be Japanese version?
Not most, but mostly here, mostly people interested in Japanese and not English because of that. Some,
Well, of course, I can make Japanese version.
thank you, Sensei.
Shall I send you?
Thank you, Sensei. Yes.
Okay, okay. I will do it today. Yeah.
Thank you very much, Sensei.
Sara-san, you're connecting now. Looks. Maybe Sara-san, maybe next time. So, shall we discuss next meeting, the date? So today is 20. How about 1 week later, 27?
I'm okay, Sensei.
Okay. Ataya-san, are you okay?
Yes, Sensei.
Okay, so let's do 27. And Zafira-san, please tell Sara-san.
Okay, Sensei.
Okay. Okay, Saraya-san, are you okay to finish? Do you have anything you want to discuss?
No, Sensei, nothing.
Okay. And Zafira-san,
Yes.
you will come to my room.
Tomorrow.
No, I mean.
Yes. はい、わかりました。
Okay, so see you. Bye bye.
Bye, Sensei.
Bye.
Thank you.
Bye bye.